So, good morning, welcome back to Sakala Vidya Educational Channel. So, we have been discussing actually infinite series. So, infinite series so far we have covered, that means actually geometric series, speed test and also comparison test. Today we will discuss D'Alembert test and also problems on D'Alembert ratio test. Okay. First, when do we apply, how to identify the test, that is very important. So, let us write the important points. After that, we shall discuss the questions one by one. Right. Let us move to our today's topic. Today's topic is D'Alembert's ratio test. Ratio test. So, D'Alembert's ratio test, when do we apply? That is very important now. So, we need to keep in mind. See, in the following cases, we apply D'Alembert's test, ratio test to test convergence or divergence. So, what are the cases? So, in that the first case is when nth term of the given series, generally you write un, contains factorial terms. So, factorial terms. So, second case, when the nth term un contains x to the power of n term, x to the power of n, when in terms of x is there n, then we need to apply D'Alembert's ratio test. Next, when un contains only one power term, Next, fourth case that you need to remember, sometimes the nth term is consisting of infinite number of terms. That means nth term may be numerator by denominator. The numerator and denominator both consisting of the infinite number of product of the infinite numbers. So, that means when un contains infinite numbers. So, these are the general cases are to be observed while applying the D'Alembert's ratio test. So, whenever you remember one thing, whenever un contains factorial terms, we apply D'Alembert's ratio test. When un contains x to the power of n term, when un contains only one power term, or un contains infinite numbers. So, that means in the numerator and denominator it is consisting of product of infinite number of terms. Okay, let us proceed for the question now. So, first question, let us try to solve the first question today's. So, note down the first question. Test for convergence of the following series. Right. So now first question, sigma 4 into 7 into so on 3n plus 1 divided by 1 into 2 into 3 into so on n. So this is the given series. So if you observe the un, nth term is nothing but 4 into 7 into and so on 3n plus 1 divided by 1 into 3 into and so on n. That means the numerator of the nth term is consisting of the product of the infinite number of terms, infinite numbers. So that's why we need to apply the D'Alembert's test. So that means already we had a discussion. See, when un contains infinite number of terms, so that means we need to apply D'Alembert's ratio test. So let us proceed. How to solve this one now? So now the solution. So let us say un equals to 4 into 7 into and so on 3n plus 1. It's not a sum, product of the numbers 1 into 2 into 3 into and so on n. So now in this case, the first we need to find out un plus 1. So un plus 1 means actually in the last term, nth term of the numerator or in the nth term of the denominator, we need to replace n plus 1. But one thing we need to keep in our mind that we should not neglect 3n plus 1. 3n plus 1 after number, that means successor of 3n plus 1 we need to write. Successor means not adding 1. So the next term of 3n plus 1 we need to write down. That is very important, keeping 3n plus 1 as it is. We should not forget it. That the 3n plus 1 is followed by its next term using the pattern. What is the pattern is there in that one? That using that pattern we need to write it. So that means now we are going to write like this: 4 into 7 into and so on 3n plus 1, compulsory must and should we need to write, and also in the place of n replace n plus 1. So we get 3 times n plus 1 and plus 1. I hope you might have followed. So divided by, in the similar manner in the denominator also, 1 into 2 into 3 and so on n write down, into next one is what, in the place of n we need to write n plus 1. Now you might have followed like this. So let us simplify this one. So 4 into 7 into and so on 3n plus 1. This, open the bracket, that means apply the distributive property. So 3 times n plus 1, that is 3n plus 3 plus 1, that is 3n plus 1. Am I right? So divided by 1 into 2 into 3 and so on n into n plus 1. Right? Now un plus 1 actually has been evaluated. So now we need to apply the D'Alembert's ratio test, that we need to apply. So now write down by D'Alembert's ratio test. What does it mean? So that means we need to consider limit n tends to infinity un divided by un plus 1. So let us substitute un, nth term of the given series, divided by the n plus 1th term of the given series, next term of the given series. So this equals to limit n tends to infinity un. So un is nothing but 4 into 7 into and so on 3n plus 1 divided by, so 1 into 2 into 3 into and so on up to n divided by un plus 1. Un plus 1 means 4 into 7 into and so on 3n plus 1 into the next term. Next term is 3n plus 4. Am I right now? Divided by 1 into 2 into 3 into so on n into next term is n plus 1. So now it's very clear that actually this term 4 into 7 into and so on 3n plus 1 by 1 into 3 into so on into n, and also this one same will got cancelled. So next what do we get now? Reciprocal of this one. So now we are going to get limit n tends to infinity, limit n tends to infinity, this is n plus 1 upon 3n plus 4. Now in order to apply the limit, my dear students, you remember, so you need to take common n from numerator, n common from denominator. Highest nth power is here n power 1, here n power 1. So this is equal to limit n tends to infinity. So to apply the limit, take n common from the numerator so that we get 1 plus 1 upon n. Am I right? So I hope you might have understood this one. In the similar manner, similar pattern, take n common from 3n plus 4. So n common, having been taken n common, we get 3 plus 4 upon n. So n got cancelled. We have now apply the limit. As n tends to infinity, 1 by n is 0, 4 by n is also 0. 1 plus 0 by 3 plus 0, that is 1 upon 3. So 1 upon 3. So what is our statement now? See, as for the D'Alembert test, whenever actually see the, whenever limit n tends to infinity, un by un plus 1 is L. If L greater than 1 converges, L less than 1 it diverges. So this is less than 1. So therefore we can state that, therefore sigma un, the given series, is divergent. S problem has been solved. So very simple. Now let us move to once again. Let me explain. See, you are asked to test the convergence or divergence of the following series. As this is the nth term of the series is consisting of the product of infinite numbers, so we can apply D'Alembert's ratio test. So first let us say un is equal to 4 into 7 into and so on 3n plus 1 divided by 1 into 2 into 3 into so on n. Now let us find out un plus 1. So that means in the place of n, write down n plus 1. So 4 into 7 into and so on 3n plus 1. It's very important. Up to these 3n plus 1 terms compulsory we need to write, and again next term we need to write. So next term, how do we get the next term? By substituting n for n plus 1. 3 times n plus 1 upon 1 into 2 into 3 and so on n, and next in the place of n plus 1. So now we need to simplify. 4 into 7 and so on 3n plus 1 into, this is 3n plus 3 plus 1, that is 3n plus 4 divided by 1 into 2 into 3 and so on n into n plus 1. Next, by D'Alembert's ratio test, we need to evaluate the limit of un by un plus 1 as n tends to infinity. Limit n tends to infinity, un by un plus 1, we are going to evaluate it. Limit n tends to infinity, un is replaced by 4 into 7 into so on 3n plus 1 by 1 into 2 into 3 so on n divided by 4 into 7 into so on 3n plus 1 into 3n plus 4 divided by 1 into 2 into 3 so on n into n plus 1. So 4 into 7 into and so on 3n plus 1 by 1 into 2 into 3 into so on n, 4 into 7 into so on 3n plus 1 by 1 into 2 into 3 so on n this will be gets cancelled. We have 1 upon 3n plus 4 by n plus 1. So we need to write the reciprocal. So limit n tends to infinity 3n plus 1 by 3n plus 4. So from numerator take n common. So we get n into 1 plus 1 upon n divided by, in the denominator let us take n common. So 3 plus 4 by n got cancelled. So we have now 1 by n, limit as n tends to infinity, 1 by n is 0, 4 by n is also 0. So 1 plus 0 by 3 plus 0, 1 by 3. 1 by 3 is absolutely less than 0. So when limit n tends to infinity, un by un plus 1 is L, where L greater than 1 it is convergent, when L less than 1 divergent. So therefore sigma un or summation un is divergent. The given series is divergent. Hence the problem has been solved. So let us move to the second question now. Second question. I hope you might have followed this question. See, 1 divided by 3 plus 1 into 2, 3 into 5 plus 1 into 2 into 3 divided by 3 into 5 into 7 plus 1 into 2 into 3 into 4 divided by 3 into 5 into 7 into 9 plus so on dash dash infinity. So on dash dash infinity. So now if you observe this series, actually the nth term of the series is not given. So we need to find out the nth term of the series. How do you find out the nth term of the series? So just observe 1 into 2 into 3 into 4, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, like that you will be getting. Okay, so now let us proceed for the solution. Right here 1 2 3 and 4 and so on n, that means actually in the numerator is also actually product of the terms. The terms are in each term in the product itself only, each term the whatever terms are there, the terms will be form AP. So we can write like this: 1 comma 2 comma 3 comma 4 and so on are in arithmetic progression. So we can find out nth term of this series. Tn is equal to, what is the nth term? Nth term will be a plus n minus 1 into d. So where a is equal to 1 plus n minus 1 into common difference is 2 minus 1, 1 only. So this is equal to 1 plus n minus 1 plus 1 minus 1 got cancelled. We have n. Nth term is n. So now you can see 3 into 5 into 7 into 9. Next one 3 5 7 9 dash dash, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, and like that you will be getting. So are also in AP only, are in AP. So let us find out the nth term of this series. Tn is equal to, a means 3 plus n minus 1 into common difference. Common difference means 5 minus 3 is 2. So n minus 1 times 2. So we get 3 plus 2n minus 2. So we get that is 2n plus 1. So now the nth term we can write here. Let nth term un is equal to, so 1 product of the infinite number of terms. So 1 into 2 into 3 into 4 into so on nth term is n divided by 3 into 5 into 7 into 9 and so on to n plus 1. I hope it's clear. Now as it is actually product of infinite number of infinite terms, so we need to apply. D'Alembert ratio test. So in order to find out, first we need to find out actually here un plus 1. Let us find out un plus 1 now. So now un plus 1 means Here already we have 1 into 2 into 3 into 4 dash dash up to n. Next number, what is the next number in the place of n plus 1 write down. So divided by, so this is we have 3 into 5 into 7 into and so on. Here this is 2n plus 1. Here one logic also we can apply. The common difference of the numerator is actually 1, add 1, that's all. Here common difference is actually 2, add 2 to the 2n plus 1, you will be getting 2n plus 3. Otherwise, if you substitute in the place of n plus 1, 2n plus 2 plus 1, you get 2n plus 3. Clear? So, the add 2 to the 2n plus 1, you get 2n plus 3. This logic also you can apply, this pattern also you can apply. So, now by D'Alembert's ratio test. So, limit n tends to infinity, un by un plus 1. That means we need to evaluate the limit of un by un plus 1 as n tends to infinity. So, this equals to limit n tends to infinity. Let us replace un. Un is 1 into 2 into 3 into 4 into so on n divided by 3 into 5 into 7 into and so on to n plus 1 divided by un plus 1, n plus 1th term. N plus 1th term is this one. So, 1 into 2 into 3 into 4 and so on n followed by its n plus 1th term divided by 3 into 5 into 7 and so on to n plus 1 followed by the n plus 1th term, that is 2n plus 3. So, now 1 into 2 into 3 into 4 and so on n by 3 into 5 into 7 and so on to n plus 1, and this one 1 into 2 into 3 into 4 and so on n by 3 into 5 into 7 so on to n plus 1 cancel. So, this one and this one gets cancelled. So, this is actually 1 by n plus 1 by 2n plus 3. So, we can write here limit n tends to infinity, you get 2n plus 3 upon n plus 1. So, now what shall we do in order to find out? So, you need to find out the limit of this one, limit of this function. So, now this equals to limit n tends to infinity, take n common. If you take n common, 2 plus 3 upon n divided by, let us take n common, we get 1 plus 1 upon n. So, n got cancelled. So, let us apply the limit. If you, as you apply the limit n tends to infinity, 3 upon n, 3 by infinity, n approaches to infinity, 3 by n approaches to 0. In the similar manner, as n approaches to infinity, 1 by n approaches to 0. So, what do we get? 2 plus 0 upon 1 plus 0. So, we get 2 upon 1, that is 2. 2 is absolutely greater than 1. So, hence we can say that sigma un is convergent. That's all. Convergent. In the previous case, that was less than 1. So, sigma un was convergent. But in this case, sigma, this limit n tends to infinity, un by un plus 1 is greater than 1. So, sigma un is convergent. If L value is 1, the test fails, then Rabi's test has to be applied. That we are going to discuss in the next class. Right. Okay, just check the question once again, all of you. Very simple, very simple. Okay, see, just observe this one. The nth term will be here actually 1 into 2 into 3 into 4 and so on n, 3 into 5 into 7 into 9 and so on dash dash. That means actually here 1, 2, 3, 4 are in AP. Then Tn is equal to A plus n minus 1 into D. Here A is equal to 1 plus n minus 1 into 1. 1 plus n minus 1, 1 gets cancelled, we have n. That is the nth term of the un, denominator, numerator, actually nth term of the numerator. So now 3, 5, 7, 9 are also in AP. Now Tn is equal to 3 plus n minus 1 into 2, 3 plus 2n minus 2, that is 2n plus 1. Now let us say un is equal to 1 into 2 into 3 into 4 and so on n. Next denominator 3 into 5 into 7 into 9 and so on 2n plus 1. Now we need to find out un plus 1. Un plus 1 means 1 into 2 into 3 into 4 into so on n into n plus 1 divided by 3 into 5 into 7 into and so on 2n plus 1. In the place of n plus 1, 2n plus 2 plus 1, that is 2n plus 3. By D'Alembert's ratio test, limit n tends to infinity un by un plus 1. Limit n tends to infinity un is 1 into 2 into 3 into 4 into so on n by 3 into 5 into 7 so on 2n plus 1 divided by 1 into 2 into 3 into 4 and so on n and also followed by the n plus 1th term, that is n plus 1 by 3 into 5 into 7 and so on 2n plus 1 followed by the n plus 1th term, that is 2n plus 3. So now this one gets cancelled, we have 1 by n plus 1 by 2n plus 3. So we write limit n tends to infinity 2n plus 3 by this n plus 1. Take n common, limit n tends to infinity 2 plus 3 by n divided by here n common 1 plus 1 by n. As n tends to infinity 3 by n is 0, 1 by n is 0, 2 plus 0 by 1 plus 0, 2 by 1, 2 greater than 1, 2 is greater than 1. So sigma un is convergent. Let us move to the third question. Third one, sigma or summation n is equal to 0 to infinity 10 plus 5i whole to the power of n divided by n factorial. So just if you observe it, the nth term, for example, if you say un is equal to 10 plus 5i whole to the power of n by n factorial, the un involves the factorial terms. That means it consisting of the factorial or power is there. So at that time we need to apply D'Alembert's ratio test only. This is the way we need to identify the appropriate suitable test. Okay, let us proceed for the solution. Already nth term given, so we need not find out the nth term. Directly we can proceed for the nth term itself only. So let un equals to 10 plus 5i whole to the power of n divided by the n factorial, right? So now un plus 1, let us find out un plus 1. How do you find out un plus 1? In the place of n, write down n plus 1. 10 plus 5i whole to the power of n plus 1. N factorial can be written as n plus 1 factorial. Clear? So now we need to apply the D'Alembert's ratio test. By D'Alembert's ratio test, we can have limit n tends to infinity un upon un plus 1. So, this equals to limit n tends to infinity un means 10 plus phi I whole to the power of n upon n factorial divided by 10 plus phi I whole to the power of n plus 1 by n plus 1 factorial. Right. So, let us try to simplify this one. Very interesting this one. See, the limit n tends to infinity, So, this we can write 10 plus phi I whole to the power of n by n factorial multiplied with reciprocal of the denominator. Reciprocal of the denominator we can write n plus 1 factorial upon 10 plus phi I whole to the power of n plus 1. But here actually you must remember two important points are to be noted. One thing remember, n plus 1 factorial as the shifting nature. This n plus 1 factorial we can write n plus 1 into n factorial. And also we have a to the power of m plus n formula, that we can write a to the power of m into a to the power of n. With the help of these two, now we can simplify. Now we are going to simplify like this. Limit n tends to infinity 10 plus phi I whole to the power of n divided by n factorial into n plus 1 factorial we can write n plus 1 into n factorial upon this we can write 10 plus phi I whole to the power of n into 10 plus phi I, right. So, now what will happen means 10 plus phi I whole to the power of n, 10 plus phi I whole to the power of n got cancelled, n factorial and n factorial got cancelled. So, what do we have now? Let us write limit n tends to infinity, we have n plus 1 upon right upon 10 plus phi I. So, 10 plus phi I is a complex number, don't worry, that is a number. So, that is a number. So, n plus 1 by 10 plus phi I. Now, apply the limit. See, as n tends to infinity, the n plus 1 also tends to infinity. That means infinity by something is also infinity by something k, where k is any real number greater than 0, that is also infinity you can write. So, that means infinity by infinity, this is infinity. Infinity is the positive infinity, that is positive infinity is always greater than 1. Since this limit n tends to infinity, un by un plus 1 is greater than 1, therefore, sigma un is convergent. I hope you might have followed. We have actually, I hope you might have understood this one, right. Let me explain once again. So, the question is summation n is equal to 0 to infinity 10 plus phi I whole to the power of n by n factorial. So, this is consisting of the factorial. So, we should apply D'Alembert's ratio test. So, let us say this is un, this one is un up to this one. So, now let un is equal to 10 plus phi I whole to the power of n by n factorial. Now, un plus 1, 10 plus phi I whole to the power of n plus 1 by n plus 1 factorial by D'Alembert's ratio test, limit n tends to infinity un by un plus 1 is equal to limit n tends to infinity 10 plus phi I whole to the power of n by n factorial divided by 10 plus phi I whole to the power of n plus 1 by n plus 1 factorial. Now, this n plus 1 factorial is n plus 1 into n factorial, whereas we have the formula a to the power of m plus n is equal to a to the power of n into a to the power of n. With the help of these two rules, we can simplify. Limit n tends to infinity 10 plus phi I all to the power of n by n factorial into reciprocal of this one, n plus 1 factorial by 10 plus phi I all to the power of n plus 1. Limit n tends to infinity 10 plus phi I all to the power of n by n factorial into this n plus 1 factorial. Factorial has the shifting nature. For example, 5 factorial is there. Simply we can write 5 into 4 factorial. In the similar manner, for example, n plus 1 factorial, that we can write n plus 1 into n factorial by this 10 plus phi I all to the power of n plus 1, 10 plus phi I all to the power of n into 10 plus phi I. This 10 plus phi I all to the power of n cancel. We have 1. N factorial cancel. So limit n tends to infinity n plus 1 by 10 plus phi I. As n tends to infinity, n plus 1 also tends to infinity. But here we have see 10 plus phi I is a number. So infinity by some number k you can say, that is also infinity. So infinity is actually positive infinity. It's always greater than 1. So as limit tends to infinity, un by un plus 1 is greater than 1, sigma un is convergent. That's all. Okay, I hope you might have followed this question. So rest of the problems tomorrow we shall solve. So in the Columbus test only. So thank you for watching, and also all of you like, subscribe and share. Bye bye. Have a nice day.